So next up is rendering. Now, that doesn't mean we're going to suddenly start talking about mantra and lighting and shading, and we certainly will talk about that, but no, we're not going to make like a crazy digression into that. We've been getting along just fine, thank you very much, with our viewport. This is a pretty decent render. This uses OpenGL, Open Graphics Language, used for video games a lot. It's used for this viewport right now. Again, real-time graphics. It's not great, but it's pretty good. It's certainly good enough to do what we're doing right now, which is just get a sense of what the shape and detail of our sim looks like. So we can continue to use OpenGL, not by taking screenshots or snapshots of our actual viewport, the way that we're doing with the flipbook, but if you go to the out area where we have our renders, just like how we could make a mantra node, let's make an OpenGL node. So OpenGL will render just the way you see here from a camera in this manner. So it's going to look pretty much like what our flipbooks looks like. Not going to be 100%, but it's going to be like 99.9% the same. So like mantra, it has the like objects. What are we actually rendering? Well, let's make a dedicated thing here. We'll call it preview. Make it green. And say this is going to be this. So I'm going to put a null. Oh, Unix. Let's put a null that's out. Oh my god, I'm losing it. There you go. Called out, like so. And that will be what this is. Wonderful. So I'll turn that off for now. Let's come back to our output area here. So that we don't want it to just render anything. We want it to just render the thing we made, preview. Sometimes this happens. It just flies over to the thing that I set it to. I'm not sure why it does that. But if I go back, oops, I should see that it did successfully put it there, and honestly, that's all that matters. So our OpenGL node, let's render a frame. But we still haven't told it where to render it to. As you might guess, much like our cache, we need to give it a wedge-specific place to write these files to. So do data/OpenGL, and then do w backtick @ wedge index backtick / frame $f.exe. If we look at it, just a regular old file path. Let's just choose a frame. I'm going to choose frame 12 here and say, well, render it. And it renders it pretty much immediately. I'm going to make another image viewer. I keep them here on my taskbar. Depending on your OS, obviously, you'll have to bring up image viewer however you see fit. If you're really lazy, you can just actually run another flipbook, and that will launch and play. But so, in my temp area, there it is, OpenGL, and we have this one frame that we just made. And sure enough, it looks like, it should look like that. There. Let's make sure. There. So it's virtually identical. I don't have the like perspective grid and stuff, but who cares? So I'm going to keep that down the bottom. We're going to need that later on. So we know the OpenGL thing is working. And now to incorporate it into our tops area. I guess we already had it there. So to do that, put a ROP fetch again. Because before we were pointing to a ROP that was rendering out geometry. But now we're going to point to a ROP that's rendering out images. So put it there. So this one is the file cache. This one is the OpenGL one. However, this time it's going to just stay on single frame. Because if I set it to frame range, it's going to do a frame range for each of these jobs. So we don't want that. We want this to do a single frame for each of these jobs. Each of these jobs already represents a single frame in a wedge. So keep it on single frame, and that's pretty much it, except if I run it, well, I'll just run it to show you. If I run it with a Shift V, it's gonna start up. It looks like on my computer, it's gonna start up 8 different instances of Houdini. Each one is gonna render one of these frames and then quit. And then it's gonna start up 8 more instances of Houdini, render out 1 frame and quit. And so on. It's not terribly efficient. It would be efficient if these were processes that took a lot longer. The thing is, rendering out any one of these frames is like lightning fast. So really what's a better idea is open up Houdini one time, which is the thing that takes the actual time involved in any of this, waiting 10 seconds or so for Houdini to start, and then you can just render all 24 frames in like 2 more seconds. So I'm gonna stop that. Say right click and say delete this node's results from disk. You can do it yourself. They are here, they're just files on disk. But if I do it here, I can say delete this node's results from disk, and you'll see they're gone now. Which is what you want, because if the files already exist, it's not going to redo them, at least not when it's set to automatic here, which it probably should be. So how do I solve that? How do I have it do all the frames at once? Well, much like the simulation here with all frames one batch, just turn all frames one batch on for this too. And that's because it is so fast. If this was like a Mantra renderer, that would be different. But look how fast they are now. Now that Houdini has started, it just chugs through it. So there you go, it's done. So let's see what that looks like. I'm going to use our flipbook from before. And there you go. Now you can see there's a full 24 frames for wedge 1. And there you go. It worked. And let's make sure that our wedge 0 looks different. And it does. So now we're seeing both sims rendered out. So that's pretty great. But we're not done yet. Now that we have those, we want to put text on the screen that says what we're looking at. Because especially later when we have a grid of a bunch of these, I might like that sim, but I don't know what parameters it represents. So let's do a thing called overlay text. Overlay text is just a nice little wrapper around a very simple compositing network that reads in the image, uses the font to put some text on it, drop some shadow, and then plop it on top. Very simple. But it's nice to not have to rebuild that every time, when all we have to do is fill in our text. So what text do we want? Well, first I want to know what wedge index am I even looking at. So once again with the backticks. Now wedge index does not have an underscore in it. However, the particle seed thing that I made did. So be careful about that. And we can always just test this. Middle click on text and see. Wedge index, when wedge is 0, particle seed is 1. So I can click on this and see that it's updating and is correct. Of course, none of these are complete without saying where it goes. So data, we'll call this overlay subdirectory. We certainly need wedging in the name still. So backtick, wedge index, frame, and there you go. And that's pretty much it. And we'll just cut to the chase again. All frames in one batch, because this too is a very fast operation. So I'm just pressing Shift V on it. Also quite fast. Once it launches the Houdini here, now it just zips through it because it's just putting text on it. So let's go look at that. So come back down. Here's our overlay thing. And there you go. Wedge index 1, particle seed 2, and the other one, I'm sure it'll be right, but there you go. See, that's what's nice about only doing 24 frames. We only have to wait a little bit, and then we can, set it to the right thing later. Sweet. And there you go. So that's all of the wedge-specific stuff that we need to do.